Hey guys, Mr. T here, just in care group. We're going to do a quick solutions video to your practice indices, exponential functions and scientific notations test. Simplify the following using index laws. So you're given the law. If you've got the same base number with different powers, but they're being times together, you add the powers. So it's going to be a to the m plus n. So your answer to this, so this is just a reminder of the law. You're going to use this. The base number is k to the power of 5 plus 3. So it's going to be k to the 8. Here we have the same thing, same base number, different powers, timesing them together. So your answer is going to be x to the power of 6 plus 3 is going to be x to the 9. M to the 6, and then all of that to the 8. So the law that you were given was a to the m, or to the power of n. And what did you do with the powers? It's going to be a to the m times by n. So your answer is going to be m to the power of 6 times by 8. It's going to be m to the power of, is that? It's not 42, that's 48. Same law here, but it's slightly more complicated. You have the base, and then it's going to be 3m times by 4. There's nothing stopping you working out what that is. 4 times by 3 is 12, and then the m's still there, so it's a to the power of 12m. Here you've got a division. Please remember that p to the, with no power, is actually p to the 1, not p to the 0. So the law you were given was a to the m divided by a to the n, and that equals a to the m take n. That's the law. So I'm applying it here. The base number is 6. The base number is p, and the power first is 6, and the second power is 1. P to the 6 take 1 is going to be p to the 5. Here, this kind of looks weird, but break it down bit by bit. Do the first two, same base number, timesing, so you add the powers. A to the 3 plus 2 equals a to the 5. We haven't done anything with this yet, so now it's a to the 5 times by a to the x. Same base number, add the powers, it's going to be a to the power of 5 plus x. You can't work out what x is, you don't know what it is, so you leave it alone. Fully simplify the following using one or more of the index laws. So just a reminder, in maths, the sign that you don't write is multiplication. So if you want to braid this up and show all the multiplications, it looks like this. Why is that useful? Because you might remember in class we said 1 times 2 times 3 is equal to 6, which is a true statement. And 3 times 1 times 2 is also 6, which is just a true statement. So what we're showing here is multiplication, the order doesn't matter. So why is that useful? We can rearrange this to make it look a bit nicer, more organized. 5 and 3 are next to each other. So 5 times 3 is 15. That's easy to work out. Here we use the index laws. I've got the same base, timesing, so I add the powers. 3 plus 4 is going to be 7. So it's 15c to the 7. Let's do the same here. It's 4 times by b squared times by 2 times by b cubed. If I rearrange that, it's going to be 4 times 2 times by b squared times by b cubed. That's 8 times by, I don't need to write the times because we don't write times in maths. b, 2 and 3 is 5. 8 to the b, 8 times by b to the 5. This looks tricky, but in class, if you practiced and you saw me demonstrating, break it up into the different bases. Also, don't forget y is to the power of 1. So the other way to do it is to show the times, put them back. If that helps you, separate everything out. 2 times by x squared times by y to the 1. Let's deal with this first. 14 over 2 is 7. Let's deal with this next, and then last we'll deal with the y's. X to the 5 over x to the 2, so you subtract the powers, it's going to be 5 take 2 x to the 3. And the y's, y to the 2 and y to the 1 is going to be 2 take 1, which is 1. So y to the 1, or you could write 7x cubed, just y. Both of these mean exactly the same thing. Again, 24 times by t to the 6 times by r to the 4 over 15 times by t to the 6 times by r squared. Let's deal with the things separately. 24 over 15, t to the 6 and t to the 6 and r's. 24 over 15. Smallest number that goes into all of these is 3. So 24 over 15 cancels out down to 8 over 5. The t's, 6 take 6 is 0. That's going to be t to the 0 times by r, 4 take 2. That's going to be 2. What do we do with this? Well, you've got 8. Better close the door. Give me a second. Apologies for that. They're chopping down trees at school. Anything to the power of 0 is 1. And then r squared I can't do anything with. So what does this do? You've got 8 over 5 r squared. I'd accept that's the same as 8r squared over 5 too. That works. This one, you have 3 times by p on the top. And q to the negative 3, all squared. What does this power on the outside do? It spreads like COVID. So it's going to be 3 times p, and that's going to be all squared. And then that squared is also going to spread like COVID to the q to the negative 3. So now we can apply the law. That squared is going to apply to the 3 squared times by p squared. Spread like COVID again. And then this one, you've got a power in the brackets raised to another power. So you're going to times it. So it's going to be q to the negative 3 times by 2, negative 6. There's nothing stopping you working out what 3 squared is. It's 9. And then you've got the p squared left over on the top. And then you've got q to the negative 6. And so what does a negative power do? Okay, it flips. Right now you've got 1 over q, 1 over q, but that's to the negative 6, so that's going to flip it up to the top, and it's going to put it to the power of 6, so you're going to have 9 p squared q to the 6. This one here, that 3 is going to spread like COVID to the top and the bottom. So you're going to have a squared to the power of 3 over 5 times by b, all to the power of 3. A squared times a squared, not times, a squared to the power of 3, 2 times 3, a to the 6, over, this 3 is going to spread like COVID, 5 to the 3, and b to the 3, a to the 6, 5 times 5 is 25, times by 5, 125, and then b to the power of 3 stays. So that is all your index laws. As practice, look at the functions below, circle the functions that are exponential. An exponential function has x as a power, so anything that looks like a to the power of, if x is a power, that's exponential. Look at the function, circle the functions that are exponential, that's exponential. X is a power, exponential. X is not a power, not exponential. X is not a power, not exponential. Exponential and exponential. Consider the exponential functions. Y is equal to 1.5 to the power of x. Fill in the table of values below for y is equal to 1.5. So x is going to be 0, 1, 2, and 3. We need to work out what y is. So do each calculation. Y is equal to 1.5 to the power of 0. Anything to the power of 0 is 1, so the first one is 1. Y is equal to 1.5 to the power of 1. Anything to the power of 1 is itself, 1.5. Y is equal to 1.5 to the power of 2. This one I can't work out myself. You will need a calculator for this. Oh, I wrote this test. I gave you guys working space. down below, so I should use it. Calculator, you'll have access to a calculator during the test. 1.5 squared, 2.25. I accidentally moved the 1 there. 1.5, 2.25, and then last one, y is equal to 1.5 to the power of 3. 1.5 to the power of 3. 3.375. That's that done. Use the completed table of values to sketch y is equal to 1.5. So when x is equal to 0, y is equal to 1. First dot. When x is equal to 1, y is equal to 1.5. 1.5 is halfway between 1 and 2. When x is 2, y is 2.25. 2.25. And when x is equal to 3, y is equal to 3.375. 3.25, 3.3, somewhere around there. Okay? Sketch it. So all I've done is dots. Now I want to draw a line, curved line through it because an exponential function is curved. That's that done. That's exponential functions. Write the following using scientific notation. What are the non-zeros? 5 and 9. What's a number between 1 and 10 that involves 5 and 9? 5.9 times by 10 to the power of. The decimal point is currently between, that decimal point there is between 5 and 9. I need to jump at 1, 2, 3. I need to jump at 4 times. So it's going to be 10 to the power of 4 because I jumped to the right. The non-zeros is 9. What's a number between 1 and 10 that involves 9? Well, 9 times by 10 to the power of. Right now, the decimal point in my 9 is after it, but I want it to jump. Is after it, but I want it to jump left. How many times? 1, 2, 3 times. So it's going to be times by 10 to the negative 3. Here I've got 6,085,000. I need all these numbers. I can't ignore that 0 because it's not just a placeholder. So I need a number between 1 and 10 that involves 6085. That's going to be 6.085. The decimal point is currently between 6 and 0, and I needed to jump 1, 2, 3, 4, 5, 6 times to the right. So it's going to be times by 10 to the power of 6. I need 771. A number between 1 and 10 that involves 771 is 7.71 times by 10 to the power of. Decimal point is currently between the two 7s. I needed to jump 1, 2, 3, 4, 5, 6 times to the left. So it's going to be times by 10 to the negative 6. Write as an ordinary decimal number. My number between 1 and 10 is 6.23. So write 623. The decimal point currently is between 6, 2, and 3, but it's going to jump to the right 5 times. So 1, 2, 3, 4, 5. Fill in the blank spaces with zeros. Done. 6, 2, 3, 0, 0, 0. My number between 1 and 10 is 3.008. So write 3008 to start off with. Because it's going to be times by 10 to the negative 4. So the decimal point is currently here, but I'm jumping 4 times to the left, so it's going to jump 1, 2, 3, 4. So my answer is going to be 0.0003008. And I'll move it over to the right so it's a bit less messy. Number between 1 and 10 is 4.597, so write 4597. Times by 10 to the 0. How many times am I going to jump? 0 times. So I'm not going to jump at all. The decimal point stays in the same place, which makes sense because anything to the power of 0, 10 to the 0 is equal to 1. So what is this question? It's 4.597 times by 1. And if I times anything by 1, it stays the exact same, which is what I got. I think that's it for the practice test. Hopefully that video helps you out, and I'll see you in the next one.